Hello dear, how are you all? Today we learn about the gradient of line and the distance between 2 points. Our goal in this video is to learn how to find the gradient of line and how the distance between 2 points is calculated. Gradient of line is the measure of the steepness of the line. Its value may be positive, negative, 0 and doesn't need to be a whole number. While the distance between 2 points is always considered as a positive quantity. Let's start video taking without more time. Take 2 points P1 and P2 anywhere in the coordinate planes and start from the point which is highest on the coordinate planes. Draw a vertical line P2, P3. This is a vertical line P2, P3 straight down from P2 towards the bottom of the coordinate planes. Then move to the first point and draw again a horizontal line from P1 until it meets to the first line at P3. Draw a horizontal line from P1 until it meets to the first line at P3. You just drew. Join P1 to P3. Join P1 to P3. Now you have a right angle triangle in front of you. Since horizontal and vertical sides of triangle are normal to each other, so they form right angle. And third side opposite to this right angle is known as hypotenuse of right angle triangle. We now want to find the length of horizontal and vertical sides of triangle. If we start to move very slowly along the hypotenuse of triangle from P1 to P2, both coordinate of P1 will change. Coordinate x will change because we are traveling to the right, and coordinate y will change because we are traveling up. Finally, when we get to the point P2, total change of coordinate x would be the length of horizontal sides of triangle, and total change of coordinate y would be the length of vertical sides of triangle. Here we represent these changes by del x and del y, and this stage we are able to find actual length of two sides of triangle. If we have particular coordinates of P1 and P2, here we suppose coordinates of P1 x1 and y1, and coordinates of P2 are x2, y2. Here we now easily can find the total change of x, which is del x. To find del x, we have to find just difference between x coordinate of point P1 and P2. We now find the total change of x, which is del x. To find del x, we just have to find the difference between x coordinate of P1 and P2. This is the distance, which is x1, and this is the total distance, which is x2, and this is the distance P1 P2, which becomes x2 minus x1, which is total change in x. We represent this change by del x. Similarly, if we want to find total change of y, which is del y, to find del y, we have to find the difference between y coordinate of P1 and P2. Here, this distance from point to x-axis is known as y coordinate, which is y1, and for point P2, total distance from point P to x-axis is known as y2. This is y2. Total distance y2. We don't want to find the difference between this distance and this total distance. We want to find the change in y, which is y2 minus y1. y2 minus y1, which is equal to del y. If we don't want to find the total change in x, we just find the difference between x coordinate of P1 and P2. And if we want the difference between y coordinate, which is del y, we just find the difference between y coordinate of P1 and P2. I mean to say that del x is equal to x2 minus x1, while del y is equal to y2 minus y1. These equation gives the distance between 2 points as well as gradient of line. Since gradient of line is the measure of the stiffness of the line and is defined as gradient of line is the stiffness of the line and is defined as del y by del x. It also can be written as in expanded form. Gradient of y is equal to y2 minus y1 over x2 minus x1. This implies that if we have a line segment, with its end point x1, y1 and x2, y2. If we have a line segment having its endpoint x1, y1 and x2, y2, its gradient will be the ratio between the difference of ordinates and difference of abscissas. Some of you may have heard that gradient of line is equal to rise over run. Very simple. When gradient of line becomes rise over run, rise. Actual rise means moving up, which become y2 minus y1. Rise means moving up, which is actually y2 minus y1. And run means moving forward, that is x2 minus x1. Here rise and run are just different names that sometimes describe change in x and change in y. We don't want to find the distance between 2 points. The distance between 2 points P1 and P2 actually is the length of hypotenuse of right angle triangle P1, P2, P3. By Pythagoras theorem, scale of hypotenuse is equal to scale of base plus scale of perpendicular. From figure, P1, P2 is the hypotenuse of triangle and P1, P3 is taken as the base, P2, P3 is taken as perpendicular. We don't want to find the length of P1, P3, which is length of hypotenuse of triangle, hypotenuse of a triangle. By Pythagoras theorem, scale of hypotenuse, which is P1, P2, scale of P1, P2 is equal to scale of P1, P3 plus scale of P2, P3. We just find the length of P1, P2. Therefore, we take square root on both sides. By taking square root on both sides, P1, P2, distance P1, P2 becomes square root of P1, P3 square plus P2, P3. As we know that P1, P3 is a distance with total change in x, which is equal to del x, we can write P1, P3 as x2 minus x1. and P2, P3, which is total change in y coordinate of P1 and P2. We replace P2, P3 as y2 minus y1, y2 minus y1. This is the distance between 2 points P1 and P2. Finally, we can say that distance between 2 points is a positive square root. Distance between 2 points is a positive square root of sum of squares of difference between ordinate and difference between abscissas. Thank you.